Alright, boys and girls, so today we're going to figure out how we can use the area of a parallelogram to find the area of a special quadrilateral called a trapezoid. So what you're looking at right now, of course, is a parallelogram. It's got two sets, 1, 2, of parallel sides. And we know to find the area of the parallelogram, we're going to use the formula area equals base times height. So for this particular parallelogram, area is, the base would be 6, and the height, which is the distance between the base and the opposite side, is going to be 4. So the area of this parallelogram would be 24 units squared. So that's how to find the area of a parallelogram, and now I'm going to show you how we can use this idea of the area of a parallelogram to find the area of what's called a trapezoid. So here's a trapezoid. Okay, this is a special type of quadrilateral. You can see it as 1, 2, 3, 4 sides. Okay, the special thing about this polygon and this quadrilateral is that there is only one set of parallel sides. There's the set of parallel sides right there. The other two sides, of course, you can see that if you were to extend them, they would meet, so those would not be parallel sides. So let me show you how we're going to change this trapezoid into a parallelogram so we can find its area. As you can see, this trapezoid has two bases. Okay? This right here we can say is like base 1. That's called the top. We can think of that as like the top base. Here's base 2. That's almost like the bottom base. Okay? And you can see here the height. That's the height. That's going to be 3 for this particular trapezoid. And so what I'm going to do is I'm going to turn this trapezoid into a parallelogram. So I'm going to look at first the top base. The top base is 3. And I'm almost going to make this trapezoid again right next to itself to form the parallelogram. But I'm almost going to do it like upside down. So I'm going to take this top base, which is 3, and I'm going to draw the top base right next to the bottom base. I'm going to make that 3 units long. Okay? So that's the top base, and I took it and I drew it right next to the bottom base. I'm going to do the opposite right now. I'm going to take this bottom base, which is 5 units long, and I'm going to draw it right next to the top base. That's 5 units right there. You can kind of see the parallelogram start to form. The last step would be to connect these two bases, and you should be able to see if that whole polygon that we just formed is now a parallelogram, which we can find the area of. And of course the area of a parallelogram is area equals base times height. Now the base of this parallelogram is the whole length. Okay? So we would have to add these two smaller bases together. So this smaller base is 5 plus this base would be a total of 8. So the entire base is 8. And the height is still going to be 3. So the area is going to be 8 times 3, which would of course be 24 units. Now, what we just found was the area of this entire parallelogram. Okay? We found the whole thing. But we just want to find the area of this trapezoid. So, 24 units squared is the area of the whole parallelogram. To find the area of just this one trapezoid, we're going to cut it in half. Because as you can see, this original trapezoid plus its upside down twin, okay, are equal in area. So if we cut that 24 in half or divide it by 2, we're going to find that the area of just this trapezoid is going to be 12 units squared. Okay? That's the area of the trapezoid. I'm going to show you another example just like it. So here we have a trapezoid. We can see that there's one set of parallel sides, and that's it. The other two sides will intersect if you extend them, so that is definitely a trapezoid. So first we're going to look at the top base, which is 1 unit long, and we're going to draw it right next to the bottom base. There's 1 unit right there. It's a little bit long, so I'm going to erase just a little bit. There we go. The bottom base, as you can see here, is 6 units long. So I'm going to draw the bottom base right next to the top base. I'm going to make that 6 units in length. Last step would be to connect these two, and there you have it. We have a parallelogram. And what we can do now, of course, is find the area of this entire parallelogram using the formula area equals base times height. The base, again, is the entire base of the parallelogram, which is made up of 2 smaller bases of trapezoids. So we have a base of 6 and a base of 1. So the whole base is going to be 7 times, the height for this one is 3. So the area is 7 times 3, which is 21 units squared. And again, that is the area of the entire parallelogram. But we just want the area of the trapezoid. So what we're going to do is we're going to take that parallelogram area, we're going to divide it by 2. Okay? Half of 20 is 10, half of 1 is a half. 10 plus a half would be 10 and a half. 10 and a half units squared. And again, that is the area of just this one trapezoid. Because we doubled the trapezoid with the parallelogram, and now we're cutting in half to find the area of just one of the trapezoids. So what you're going to do now with a partner is you're going to go to page 559 in your folder, and you'll see that there are 2 problems that show a trapezoid on grid paper. What you're going to do is you're going to do the same thing that I did. You're going to turn each trapezoid into a parallelogram, find the distance of the whole parallelogram, and then cut it in half. When you're done, Mr. Lovering is going to call some of you up to show your classmates how you found the area of just the trapezoid. Good luck.